So you're handed a query, and there's a very large space of ways that you could go about answering it. What makes that search genuinely hard?
Yeah. So, for example, we can consider, a simple query like somebody might be interested in what is the correlation between ice cream salt and the weather, right?
Mm-hmm.
And that's the question. So there are like tons of ways how we can interpret that, right? So what does the weather mean? Is it like temperature? Is it sun, like
The forecast,
the forecast, like the number of sun hours, right?
Mm-hmm.
Where is it, right? In which country? What is like the time period that we are interested in, right? And yeah, so there's like tons of ways how we interpret it, and then we usually we could go and explore and run the algorithm for a very long time. But we also want to be able to provide some answer quickly. No, so we need kind of like really a good way, a good algorithm that can figure that out.
Yeah, I feel like so a lot of the things that you mentioned, of course, come together and make it even harder, right? Because it's not only that any particular bit of the query can have multiple interpretation. It's also the combination of those that together may not have any meaning or may no longer make sense. In isolation, each of those could be okay, but when you try to combine them to give a meaningful answer to the query, they suddenly stop. But it's not only that. So of course, the space of the search it's very big, but it's also the fact that every step we take in answering the query can take a significant amount of time.
So do you have an example, like what would happen to the ice cream part of the query, for example?
Yeah, so of course I can imagine that you will need to in some way connect to an API. That
Mm-hmm.
would take some time. You will need to download some data, process the data. This is something that you really want to do carefully so that you don't do too much.
Yeah, of course. Like you don't want to kind of like upfront download the data from, I don't know, all European, American, Asian countries, like, right? And then you have all the data and you spend minutes, and you might not need actually all of it, but you even maybe spend already even money for getting the data.
And I guess you also want to avoid this really kind of dead ends, like, we do have maybe knowledge and information about the flavors of ice cream that exist in the world, but that's completely irrelevant to this problem. Right?
Yeah,
and
yeah,
we kind
totally.
of need to figure out, right, I need to use something about ice cream, but in the context of computing the correlation. So a bunch of this knowledge needs to be discarded. We need to figure out what is relevant, how can we use it. That's
I feel like there are a big important part of that is, trying to identify as early as possible what pieces of knowledge are the most related to the thing that we are asked, and also to balance between checking too many combinations and trying to get to something reasonable as an answer to the user that we can then refine if we need some more precise output.
I guess the key thing is like getting something reasonable in a short amount of time, because we can explore all these immense possibilities, but in the end, nobody wants to wait an hour to get the all existing possible ways to answer this question, which mostly would maybe lead to nonsense or wrong answers.
So how would we kind of like train our system or steer it to get in these situation to be able to answer something more quickly?
Right. So something that is really strong with our system is we really have a symbolic system, right? So we do have a notion of it's an ice cream. It's not just value or kind of a one hot encoded vector or something like this, and we do use that to figure out how can I connect the dots in the most efficient way possible. And I think that's really one of the most key of our approach.
Yeah, then definitely. So all of these, of course, we can see that all of these combinations, all of these possibilities are naturally understood under some probabilistic framing, and we can also leverage that framing to try to learn from the past, and that way we can try to be more and more targeted over time. The important part of this, of course, is that we don't need a human picking particular possibilities at any given time, because otherwise that would make it extremely time-consuming and infeasible to do in large scale.
Yeah. yeah, this like feedback or this kind of self-feedback approach is probably one of the important aspects, which is, did we do good? How can we refine what we do?